Well, hello friends. Welcome back to OS Hacking. Today we are going to work a little bit on hardware support. So a while ago, for my birthday this year, I was sent this here RGB enabled mouse by Jesse, and it has more buttons than my previous mouse. This actually has these side buttons that I guess are bound normally to like backward and forward. And then it has a button on the top as well, but I'm not really sure if that button is used for anything. But at least the fourth and the fifth button that are on my thumb, I figured we could make Serenity recognize those buttons. So the first thing though is that we're going to need some kind of app, because it's a bit annoying that we have no way to test out mouse events, and it would be nice to just have it like a stupid little demo app or something that shows what stuff you are clicking. So we'll just make a little demo. Copy the hello world makefile into mouse. Oh, that did not go well. Mac makefile, all right. Mouse. We'll just make a little mouse demo. Okay, and then let's see. Maybe we should have a main CPP here actually. All right, mouse main. So what we want here is just a very simple little thing that maybe shows which buttons are pressed right now, something like that. So let's hack that together. The GUI widget. Okay. It's been a while since we wrote an app from scratch. Okay, so there's our basic skeleton, and then we need a window. Show that, and we'll need some kind of widget in that window, so a main widget. We'll just make it a regular GUI widget, no big deal. And maybe we'll set his layout to be a, I don't know, vertical box layout maybe. GUI layout, and then let's just add some helper widgets here. So I guess we can just, maybe we should have some frames actually, because frames look very nice. From A, we'll make that guy a frame too. Okay, and then maybe we will create a special class like a button, mouse button indicator. Something like that. Virtual mouse button indicator. It's a GUI widget. And then we will, actually let's make it a frame. And then let's instantiate a couple of those. So we'll say left indicator is main widget, add a mouse button indicator, left. And GUI mouse button left. All right, left, middle, I guess, right, and then we can call these back and forward. So this will be, oh, why did I do it this way? Right, back, and forward. I think those are normally the names you would use for these buttons. And of course we don't have those yet, so we'll have to add them. Back is 8, and forward is 16. Since this is a bit mask that we normally use for buttons. Okay, and then I guess, let's see here what we do with this. So GUI, mouse button. We'll store that somewhere, so M button. Okay, and then I guess we should also hook these guys up somehow so that maybe we don't need to actually store these anywhere, but we need to hook them up so that when we click somewhere, then these guys will react. So let's see. We'll do a paint event. And the way we'll paint these is we'll just make a painter for which we'll need the GUI painter, and then clip it to the event rect, paint the frame first of all actually, and then what we want to do is if, wait, I guess we can store the button state in a global. Who cares if we use a global, right? Mouse button state. If it has our button, then we will fill rect with white, or maybe we should fill it with black, and then we'll fill it with white otherwise. Something like that, and then this will be our start. Actually, we can do something like this. Painter fill rect, background color, and draw text. The button name or name, and we will draw it text alignment centered, and the color shall be the foreground color. Okay, and then the name, we were already passing the name to the constructor, so here we'll just say string m name. Okay, and then finally so if it is clicked, then the background color is color black and the foreground color is color white. Otherwise, it should be straight up the other way around. Okay. So that's pretty cool, and then all we need is to react to these mouse events. So we actually need a custom widget that remembers all the mouse events, or at least the last one. So we can't use just a generic frame here. We'll just call it a main widget. So it's supposed to be really easy to make widget classes. So all that you really need in this case is just a constructor. I like to add a virtual destructor, but actually you can probably get away with that one. Let's see what happens if we don't even add one. And then in this case, we need the mouse down event. And then here we'll just say event, or no, s mouse button state is event buttons. I think that should be it. Actually, we can pass the event through to our parent class. Yep. So we're just spying on the mouse event here. And since this widget doesn't implement any mouse event handling, it's just going to ignore mouse events, and they will go to the parent widget instead. So let's see if that builds. Nope. Incomplete type vertical box layout. Well, that makes sense. We never actually included box layout. Okay, and we'll just need to make sure that we install the mouse demo. Okay, so let's test this out. Oh shit, we have to actually trigger a repaint if we want something to change. So when we get a mouse down, or I guess a mouse up for that matter, mouse up, and then in both cases we will update. Update will just cause the window to get repainted. This is not working as well as I was expecting. So let's see. The background color is white, so the state is not set. And I am making a main widget, but are we not getting these events? State. So let's just log that we're doing these just to see what's going on. Mouse down and mouse up. Oh, wait a minute. If I click in between, it works, but if I click on them, it doesn't work. But it's not supposed to be like that. Why is it like that? Wait, maybe I have to explicitly ignore the events. I guess I have to actually. Oh, okay, that was... I had the wrong idea. We have to go here and actually implement mouse down event and mouse up event in the indicator class and just say event ignore. That is what will cause it to be passed to the parent. Sometimes I forget how things work in Serenity, and it takes a moment to like remember, but here we go. Okay, now we have all these guys left, middle, right. And then of course back and forward don't work yet. But I think this will be a helpful little test app for this purpose. So let's see, I guess we can set a nice little window title. Set window title, mouse button demo. Okay, and now for the interesting part. We are gonna have to look up how to enable these buttons, because I remember for the mouse wheel, let's go and look at the mouse driver. For the mouse wheel, to send us like mouse wheel packets, we have to send this like magical initialization sequence to the mouse to tell it like, hey dude, if a wheel, it's okay for you to send wheel packets. And it is here. Right, so if the device ID is not an IntelliMouse ID, then we send the magical wheel initiation sequence. And I'm pretty sure that there is a magical like 5-button init sequence as well. And there's this web page. It's called Andre's keyboard and mouse something. No, just keyboard maybe. This one here. Yeah, this one. This guy has all kinds of interesting information. So the PS2 mouse protocol. So this is the standard protocol uses 3 byte packets. So that's what you normally get. But if you have a wheel, then you get a 4th packet that has the wheel delta. And if you have an IntelliMouse, which is the wheel mouse, then it talks here about the magical init sequence. So the initialization sequence, that's what we were sending here. So what you do is you set a mouse sample rate, and then you set another mouse sample rate, and then another one, and that's how the mouse knows that you're telling it something secret. So it appears to be what we want right here, no? The Explorer mouse protocol, scrolling wheel and 5 buttons, which is activated by first sending the magic sequence for IntelliMouse, which we already do, and then when the IntelliMouse ID has been seen, you send this magic sequence, sample rate 200, 280, and it returns ID 4 instead of, I think, ID 3 is what we're currently getting. So this one is called the IntelliMouse Explorer, so we'll just add that here as a potential ID. And then let's say that if device ID is PS2 mouse, so if we've enabled IntelliMouse, then we should try to enable 5 buttons as well. Then what we'll do is we'll send the PS2 mouse, set sample rate, wait for an acknowledgement, and then the sample rate was supposed to be 200 and then 200 and then 80, right? So 200, 200, 280. And then after that, we'll do a get device ID, and then fetch a new device ID. So at this point, we can then check if device ID is PS2 mouse, IntelliMouse Explorer ID. So this code is a little weirdly nested, honestly. I don't love the way that we're checking the same condition here. Maybe we can reorganize it a bit, but also this is very repetitive. Why isn't it like this instead? Set sample rate. Rate. Something like that. Maybe that should be a helper function actually. Set sample rate. Put that here. We'll just ignore any kind of error at the moment. Okay. I think we'll assert if we don't get an error, right? That's what I expect. Yeah, so if there's a protocol failure or something, we'll actually just assert. This is not perfect, but it is what we do right now. But at least this allows us to write this in a much more concise way. So we can actually fix up the IntelliMouse wheel in its sequence to be like that. And then down here it was 200, 280. So look how much nicer that is. And this get device ID could be better too. So let's improve the mouse driver. Get device ID. And then all you have to say is PS2 mouse, get device ID, expect ACK, return moose read. Get device ID. Okay, and then this becomes even nicer. So device ID is just a matter of saying get device ID. Look how much nicer this is getting. Get device ID. All right. So here we'll just say something like PS2 mouse device, 5 buttons enabled. Okay, so I don't know what's going to happen once we enable this mode because we haven't had it before. And oh, and I guess there's going to be a fair amount of rebuilding. So let's look at the mouse packets. So with the wheel enabled, we have 3 packets. So wait, a 3-byte packet. What am I even looking at here? So let's look at our mouse packet class to see what it looks like. So we have X, Y, and Z. Z is the wheel axis at the moment, so we'll just add some stuff here like back button and forward button so that they follow the same as the GUI mouse button. Oh crap, where did we define that? No, not enum class. Enum? Back 8, forward 16. Yeah, that's good. And oh, this is used by the VMware backdoor. We have to do this for VMware also. But maybe that's okay. So we have there are basically 2 modes of function in the mouse driver at the moment. On real hardware or on emulated real hardware, we use like the normal PS2 protocol. But if we detect that you're running inside QEMU or VMware or something like that, like VirtualBox, then we talk to the VM that you're in and allow you to move the cursor directly in and out of Serenity without having to lock the cursor inside the VM or whatever. So it's just it's a very nice little thing that is the reason that I can just drag my cursor from out here to here and just seamlessly. Otherwise, if I click in here, or what's the thing that I do? Control-Alt-G. Yeah, so now the cursor is grabbed. But normally I can just go in and out because of the alternate protocol that we use. So let's see what happens now if we enable this mode, if we get some message about it or something. Where did we start the mouse? Device detected. No mouse wheel detected. Well, that's a bit suspicious. Is that even true? No, I'm clearly wheeling. Did I just mess that up? We shouldn't be having this guy right here. No mouse wheel detected. Let's just log what our device ID is. Device ID. And just for simplicity, let's hang the kernel right afterwards so we can just see it here. 250. I feel like I must have messed this up somehow. $250. Wait a minute. What were we doing previously? Write get device ID, expect ACK, mouse read. Set sample rate. Oh, wait a minute. I'm not waiting for the ACK after I send them the sample rate. So now we should have a more, 3. That's a better number. Okay, so let's see if we can go into the Explorer 5-button mode. What say you? Look at that, 5 buttons enabled. That's pretty cool. But we're not passing anything all the way here yet. So now we gotta go and look at the interrupts. So let's see. In handle interrupt request, so we do have a VMware backdoor. So let's go in there and look at the way he receives a packet. VM mouse left click. I bet you that these buttons are in here somewhere. How do we find this? Maybe we can look in the QEMU sources. And this thing. Middle. No, how do we find these? Oops. Oopsie. Okay, let's just go down here. Read ID, disable, blah, blah, blah. What is the thing that we're fetching? VM mouse data. Okay. Call something called VM mouse data. And that we are just reading something from a queue. All right, so who puts stuff in that queue? Mouse event. Putting in the button state. I don't see any more buttons here. So maybe QEMU doesn't support my special buttons in this mode. It doesn't look like it would, because it's only setting bits for left, right, and middle. So we may need to be limited to the legacy or like the non-VM aware mouse driver. So we'll have to turn off the QEMU stuff or the VMware backdoor stuff. Let's just Oh, we have a way to turn it off. Okay, so we can turn it off at when we spawn the kernel. Oh, how do you do this again? QCMD. VM mouse off. All right, let's see how that goes. Now, see, yeah, it doesn't react now to me moving the cursor in, but if I click, take over. All right. So let's see. So now we gotta go in the PS2 mouse device, and here is our little state machine for processing mouse packets. So the way the mouse works is that you get an IRQ, and then you read 1 byte from the mouse, and then you get another IRQ, you read another byte from the mouse, you get 1 more, you read another byte. And in our case, we read 4 bytes, because that if we are using the mouse wheel or the 5-button protocol, then we have to read 4 bytes to make 1 packet. And what we do here is we call, once our data state is final, then we call parse data packet, and then go back to the initial state. And then here is where we extract from this is the raw data packet basically from the mouse. And this is just us extracting like the different X and Y coordinates and stuff like that. So buttons, we just take buttons from the bottom 3 bits of the first byte of the data, but I think that's where the left, middle, and right come from. But now we're gonna have to actually look at the 4th and 5th. So we'll say if M has 5 buttons, which we should have invented already. So next to has wheel, we'll also have like this guy, just so we know that we need to extract that. Okay, and where is the stuff stored? So it is stored in this thing is so really weird to read. I don't understand how to read this table here. Why is it so strange? I guess these are the bottom bits. But is there something wrong with this? Like I feel like the number of rows in these tables is all goofy. Oh wait a minute. Oh wait, no. It's just that I'm thinking that these are headers, but they're not a table header. They're just so it's byte 1, 2, and 3, and then bytes 1, 2, 3, 4. Yeah, okay. That wasn't just me being stupid. I kept thinking this is just the names of the different things, and then here are the individual things. But they're not headers. Okay. That means that these are the 3 bits that we just looked at. So the bottom 3 bits of the first byte. So the 4th button is here, and the 5th button is here. So it's the 0, 1, 2, 3, 4th bit and 5th bit of the 4th data packet. So that would be packet if data 3 and then packet buttons mouse packet back button. I don't know which is which, but now I'm realizing that maybe QEMU is not going to emulate this here either. So we'll see if this actually does anything. It might only work on real hardware, but maybe we can fix QEMU actually. Let's see if this does anything. Oh wait, I needed to run this way. Okay, and oh, well, it's doing something, but not at all what I expected. Oh wait, I know what it is. Or do I know what it is? Packet buttons. This is not valid. I can't do it that way. This is what I'm looking for. Hex 16. That's not what we wanted. We wanted hex 10. It's a little bit weird to do this, but yeah, that makes sense. Okay, so at least it was reacting to that button. That's really good. And now I ran it the wrong way again. So it doesn't do anything, but it was clearly reacting to me pressing it that way before, so maybe now the issue is in the Windows server screen class where we take in this mouse data. Yes, so we need to generate mouse down or mouse up events for these fellas. Mouse button back. Wait, didn't we call it that? We also, there's so much duplication of these. There's one in the kernel's mouse packet structure, and then there's one in Windows Server in his mouse button structure, and then there's also one libgui in his mouse button structure. So it's a little bit unfortunate, but it is a simple structure. It's just annoying that they have to match up, right? Okay, so now we will send mouse down and mouse up for these as well. And we just have to rebuild Windows Server for that. Oops. It's a bit sad that the QEMU doesn't have 4th and 5th button support in the VMware thing, but maybe that's a limitation of the VMware Absolute Mouse protocol. Wait, I didn't start it right, did I? I have to remember to start it right. Oh shit, what did I just do? I don't know what I just did. Let's try that one more time. I definitely did something wrong here. Okay, wait a minute. Just clicking the 4th button makes everything go haywire. Why is that happening, I wonder? You are just completely falling apart in Doubleclick info. Oh shit. Doubleclick info. I think we're indexing into an array assuming that it has as many entries as there are mouse buttons. Or something like that. Wait, click metadata. Metadata for button. Oh wait, no, it's just an assertion. Okay, so it's not even that bad. We just have to teach it. Teaching him how to detect double clicks for the back and forward buttons. It's a little bit strange, but I guess we can let you double click these. Why not? Click metadata for the back button and for the forward button. So double clicking works, it's implemented in the Windows server, and he sort of tracks when was the last time that you clicked with a specific button, and which window did you click on, and where did you click. And then based on all that information, we can decide when a second click comes in, is this a double click? Because we only do that if it's I think it's like if it's within a certain range of the first click and within a certain time frame and so on. And in the same window, obviously. Anyway. I didn't start it right this time either. Dang it. Okay, come on now. Well, now we just killed this program. So we have an assertion in Windows Server connection. So this is the libgui connection to the Windows Server. And I bet you that we are choking here, right? We're getting a mouse button as a plain unsigned 32, and then we're converting it to a libgui thing. So we already know the drill. We'll do a quick rebuild of just a mouse program, I think. Try not to do this click to anyone else. And I started it the wrong way. One of these times I'm going to start it the right way. Forward, backward. Ooh, look at that. They work. That's pretty cool. Man, that took a moment. But that's awesome. I wonder what happens if we do start it the wrong way. Can we actually... It shouldn't work, but if I do this now, then it doesn't react, you know. That's really unfortunate. VMware mouse protocol. Is this defined somewhere? Is this just something that we could fix in QEMU, I wonder? Because if this is something that works in VMware, let's search for this string. VM mouse emulation. Where do these guys... Okay, can we find the Xorg maybe implementation of this? How do you find the source code of Xorg drivers, I wonder? Maybe here. Okay, source. Presumably this is the Xorg driver for VM mouse. So mouse button event. And wait, where are the buttons? Buttons, true buttons, blah, 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 blah. Okay, so who calls this? This guy right here, host event. So what are the buttons? Well, oh, this was an easier way to do it. Mouse motion event. Okay, so they're just not tracking the back and forward buttons. Fourth, fifth mouse button, back, forward. Is that what they're called? Back and forward. Yeah. Forward. I wonder if they're sending the data and just nobody knows how to... Thinking maybe in VMware they actually send this information and just nobody knows. Or they know, but like the people who did the Xorg driver maybe didn't care because it didn't have a 5-button mouse, and then the people who did QEMU just copied whatever the Xorg driver was expecting, and then now we're here. I don't know. I mean, we could probably send something. So how does this even work in QEMU, I wonder? What are these things? Button. Okay, so they don't even have a concept in QEMU of 4th and 5th button. Okay, well, we're just going to leave that one alone then. Maybe someday someone will come along and add those things to the QEMU and VMware protocol and so on, but we're not going to do that now. So I think we'll start by just adding the kernel stuff. Kernel extend support detect 5 button mice and if present mouse. Yeah, let's say that. The detection works very similarly to how we detect a mouse wheel. Just another magical sequence of set sample rate requests to the mouse, followed by an ID check. Yes, that's pretty nice. And then we will do the libgui and Windows Server changes. Wait. Windows Server plus libgui support the 4th and 5th mouse buttons. We'll call these back and forward, since that's what they normally get, that what they are normally mapped to in other systems, I think. At least that's what I'm used to. Like if I click on the back button here, yeah, it goes back. See? Forward. I didn't set that up. Like it's just a default behavior, so that's why I was calling them that. And some other systems. Maybe we'll find, no, well, we don't have to. We don't have to decide right now what they're gonna do, but I think back and forward are okay names. Because even like if they don't make them do back and forward in the UI, the name still kind of makes sense, because back is like move my thumb back, click back, move my thumb forward, click forward. So that's okay. And then this silly little mouse thing. How does that even look? How does it even look? It's not the most beautiful demo. We could have a little bit more spacing around the main widget. It would look a bit better, I think. Demo mouse main. We'll just say set margins 4, 4, 4, 4. And I'm running it the wrong way. But actually this time I just want to see what it looks like. Okay, well that looks weird. That's not how I meant for it to look. And let's do 8 here instead. I guess we're missing a fill with background color. Yes, sir. Boop. Moose, and that looks a little bit weird. Why does it look so weird? And also, what happened there? Somebody died. Windows Server connection 182. Oh shit, wait. We didn't do a full rebuild, did we? I guess not. Who died? Who died? What says number 9? File manager died. Oh, the desktop. Okay. Yeah, so I just need to relink the file manager and this will work. But this doesn't quite look the way I wanted it to look. I don't know why I care so much about this right now. I guess if we make this into a frame, then it will probably just look a bit better thanks to the magic of frame. So we'll try that. Moose. Okay, it looks a little bit weird, but it's also kind of cool. Okay, but now these guys don't look right. At least the frame outline here I quite like. Let's just make the indicators, because they are frames, but we are filling them too much, so we should use the frame inner rect here, so that we get the proper frame look around them, and they will look like these sunken containers. You'll see what I mean when we bring it up, like that. Now it's like we're right there, back where we're supposed to be UI wise. Very tidy. Now it's almost like the surrounding frame is a little gratuitous. So what if we live without the main widget being a frame? How would it feel then? And if we do without the margin as well? We're getting into the important details now. But if we don't do this nicely, then it's going to bother me so much. So yeah, that's pretty cool. Yep. I like it. And this could clearly be a more advanced demo. You could add all kinds of interesting things, but I think right now we'll be happy with just this. But I think in the future maybe we could add like a mouse wheel display and maybe show where the cursor is on screen, stuff like that. Anyway, let's add this as a tiny little demo. Cool. Demos. Add a little mouse demo for showing mouse button states. This was very helpful when adding support for 5-button mice. Cool. So I think that's going to be it for today. I am really glad that I finally have support for the 5-button mouse that was sent to me by Jesse, who is one of the earliest people who joined the project. So thanks again, Jesse, for the cool mouse, and now I can actually use it to its full potential inside Serenity, which is just really neat. Anyways, this will be the end of today's video, so if you made it this far, then I thank you for watching, for hanging out while we do something a little hardware-y, and I hope you saw something interesting, and I will see you next time. Bye.